of experiment. Also, at first we have some bugs in our training code, and after we solve all these problems, we can get. And when we introduce more and more tasks, we are surprised that it can work for all of these tasks. And so that's the logo models we can build. And I think right now we are also facing another challenge we are not solved today. That's the trade-off between the natural language and the science language. So in our training or in our experiment, when we increase the natural language training data, the science ability reduce. So we didn't find exactly, and the skill of the model is the skill of the model, and also
that project and much more experiments in the paper and results.
So the most I think the most thing surprised me, I think, is the application study for the model part. And as I said, when we starting the AF science research, so we train some domain specific model, and we train the model from scratch. And we also try to use some base model to initial our transformer, but they didn't work. But for this logo model, so when we enter the random initialization, so that give us a very promising directions. So we can use the large language model as the. I think that there's also embed all this give us
Promising. So I think we've the results and the surprises you've found through the research. So now I'd love to talk about something more broader. So the first question would be, looking ahead, how do you see logos being used in real world? Will it have
and it gives a very promising science model. And you can see